Welcome to methamphetamine. Today we are going to do the integral of s psi of x over x times the parentheses x squared plus 1 going from 0 to infinity. So s psi of x is mean the psi integral. So we are going to use the Feynman technique once again, right? We let I of a is equal to the integral of s psi going from 0 to infinity s of ax and then x times that. So we are going to differentiate both sides. You get I prime of a, which is equal to our, let me just write down the 1 over x times x squared plus 1 first, because it's a constant in the a world, and then we are going to multiply by the derivative of s psi. So derivative of s psi, first you are going to get psi of inside over the inside, right? Psi of x over x. And then we're going to multiply by the derivative of inside, which is x is just a constant in the variable, So you can see this x and this x, they cancel each other out. So you are going to get the integral of psi of ax over x times x squared plus 1 dx, going from 0 to infinity. So what is this integral though? So I have done this integral before, so you can check it by one. I think I haven't done this integral. But let me put down the result of this. So this result is just equal to pi over 2 times 1 minus 1 over e to the a power, like that. So let me just distribute inside, so that can help me to integrate both sides later, right? So we are going to get pi over 2a and then minus pi over 2 times a times e to the a, right? So we are going to integrate both sides now. So I of a, which is equal to pi over 2, and then integrate 1 over a, you get ln a. We do not need an absolute value here, because we assume that a cannot be a negative number, So I hate when this a is a negative number in the Feynman technique. So that's my hobbies. So this original integral, that a can be equal to 0 as well. So a should be greater or equal to 0, because when you put a into this, you get s of 0, which is a 0. So that integral will be converges. So we're going to put the negative pi over 2 in front. So what's the integral of 1 over a times e to the a? So let me just do more work here. The integral of 1 over a times e to the a dA. So let me just bring this e to the a on the numerator, so you will get e to the power of negative a over a dA. And then we are going to use our substitution. Let u is equal to negative a, and then our du will be equal to negative dA. So dA is just equal to negative du. Put the negative side outside the integral. Then e to the power of negative a, which is just u. And then our a, which is just negative u du. So negative and negative, they cancel each other out to become positive. So you will get the integral of e to the u over u, which is just equal to our exponential integral. And then our u is just equal to negative a plus c. So this integral is just equal to negative pi over 2 times ei of negative a. And then we are going to plus c here. We are going to figure out what's the constant here, because c is not always c is not always 0, So this is equal to that, right? Si of ax over x, this integral. So ei, look at this, ei of negative a. If a goes to infinity, this will become 0. But when this goes to infinity, you pretty much just get infinity. Then when this goes to infinity, the s side of infinity, you'll get pi over 2. But this integral 1 over x times x squared plus 1 going from 0 to infinity, that integral will be divergent as well. So we cannot let a is going to infinity. We have to do more work, I think. So a can be equal to 0 in this point, right? Because the original integral converges. So let me just, but however though, a cannot be exactly equal to 0 because L1 0 which is just undefined, right? So I'm going to take the limit, let a goes to 0 plus. It should be 0 plus because 0 plus means number that is really closer than 0, but they are bigger than 0, a little bit bigger than 0, like 0.001, 0.002, like that. So I'm going to take a limit, and then we are going to factor out the pi over 2 here, and then take a limit of a approaching to 0 plus, and then ln a minus ei of negative a plus c, which is 0 2. And then put 0 into it. You can put 0 into it here, and then which is just 0. So entire integral will become 0 because 0 doesn't have the area. And then what should we do here? Ei of negative a. When we put 0 plus inside, negative, we can just ignore the negative. So let me just ignore the negative because ei of negative something, and then 0 plus. Let me just ignore that. Ignore that negative here. Because we can do our what's this limit though? We are going to use more check here. So ei of our a, you can write this as our what? You should remember this is equal to our Euler-Mason's constant, and then plus Lnx, right? And then plus our summation as n is equal to 1, and then infinity, and then x power of n over n times n factorial. This is the definition of the ei of a. But this in our a row, we should change this x into our a, So we can just distribute the negative inside. Right? Let me just, I don't have enough space to write a plus c here, so I may write as c plus. It's never mind, So c plus pi over 2 times limit of this. And then we are going to distribute the negative side inside. ln a and ln a, they cancel each other out. So you will get the negative of the Euler-Mason's constant and the negative of that, and the minus the summation as n is equal to 1, and then it goes to infinity, and then a power of n over n times n factorial, which is equal to 0. So I forgot about the plus. It should be still plus here. And then put 0 into it. This entire summation will become 0. So you are going to take a limit of that, which is just equal to the negative Euler-Mason's constant. So for c minus our Euler-Mason's constant times pi over 2 will become 0. So you can see our constant c will become our Euler-Mason's constant times pi over 2. So that's really cool. Wow, that constant is really crazy, Euler-Mason's constant. And let me just give you a hint. Euler-Mason's constant is about 0.8 0.578. I remember about 0.578. So ladies and gentlemen, so I of A will become, it should be become, no S, and I of A will be equal to pi over 2 times ln A minus pi over 2 times EI of negative A, and then plus our Euler's measurement is constant, and let me just pronounce this as gamma. You can also read this as gamma times pi over 2. So our original integral, which is just put 1 inside, right? Put a 0 to 1. So this integral of si of x over x times x squared plus 1 dx, which is just 0 to put 1 inside, you get 0 here, and then put 1. EI of negative 1 just stay the same. Negative pi over 2 times EI of negative 1. And then EI of negative 1, because it's neither an odd function or an even function, you cannot put the negative side outside. So what this says, EI of negative 1. And then add our Euler's measurement is constant times pi over 2. And this is just our result of this integral.